So we're doing problems based on kinematic equations of uniformly accelerated motion. So we did basically we did four types of questions. One was based on displacement, second was based on acceleration, third was based on determining the velocity. I think we did one more. Yes, a vertical projection from a height or from the ground. So now let's take up another case which is almost similar to the vertical projection, except for the fact that there might be minor differences in the signs being used. So what we are going to discuss in this series is kinematic equations for solving problems where the situation says the body is dropped from a height, okay, and not thrown from a height. I think I have included one or two questions from thrown from a height also, but most of the discussion will be based on a body which is dropped from a height. Let's start solving the first question. A boy standing at the top of a tower 20-meter height drops a stone. Assuming the acceleration due to gravity is equal to 10 meter per second square, the velocity with which it hits the ground is. So, what's given is there's a tower and a boy stands on top of it. He drops a ball or he drops a stone, and the height of the tower is given to be 20 meter. Since the ball is dropped, we can say that u is equal to 0, or let us make it more precise. So the path is from A to B, where AB is the height of the tower, which is 20 meter, and say it strikes B at a particular velocity v. Now we know by equations of motion that v square minus u square is equal to 2as, which means v square minus u square is 0 square is equal to 2 into a is given to be 10 meter per second square, 10 into s is given to be 20 meter high, it's 20. So we say that v square is equal to 2 into 2 is 4, 10 into 10 is 100, so v square is 400, in which case v is root of 400 and v is therefore 20 meter per second, which makes the correct option as option B, 20 meter per second. A body freely falling from rest has a velocity v after it falls through a height h. The distance it has to fall down further for its velocity to become double s. So this is a really simple question, but the way it has been presented, it feels a bit intimidating. But I would say just drawing a diagram would help making the question feel simple. So it says, it goes like this. So the body is being dropped from A, and the velocity here is initial velocity u, which is 0. So it has falling from rest, has a velocity v after it falls through a height h. So let us say this much distance is h. And at this point, the final velocity, let us call that point as P, where the final velocity v is given as capital V. Now the ball is still moving downwards, and it is given that at some point C, the velocity is 2 times v. Or basically, you can say that velocity at C is 2 times that of velocity at B, right? And the question is to find out this height. Okay, so let us consider for the motion along AB. Right, so we have for the motion along AB, v square minus u square is equal to 2as, right? So u square is 0, so v square minus 0 square is 2 into as g, and s, how it's given to be h. So we can say that v is equal to root of 2gh. Now what is v? V is the velocity at point B. So we can say that vb is equal to root of 2gh. Now according to the question, right? There is another condition given, which is that VC, velocity at C, is 2 times velocity at B. which means velocity at C is equal to 2 into velocity at B, which is basically root of 2gh. Now let us apply the equation of motion here. What do we get? V square minus U square is equal to 2as. What is V? V at C. What is U? Is U at B. What is A? A is G. So V square is 2 times root of 2gh, the whole square, minus U square is root of 2gh, the whole square, is equal to 2 into g into s is what we need to find out. So 2 square is 4, root of 2gh is 4 into 2 into gh, minus root of 2gh square is 2gh, is equal to 2 into g into s. So which basically means s is equal to, so 4 2s are 8, 8 minus 2 is 6, 6 gh, the whole upon 2 into g. So g and g will get cancel off. So 6 by 2 is 3. So we get s is equal to 3h. Which means the given options, among the given options we have, right, option C as the correct option. If a freely falling body travels in the last second a distance equal to the distance traveled by it in the first 3 seconds, the time of travel is. Okay, so the given question says distance traveled, so called as s in the last second, is equal to s in the first 3 seconds, which means s at t equal to 3. Now, what is s in the last second is basically Sn. So we have Sn is equal to s at t is equal to 3. So let us individually find out what is s at t equal to 3. See, s at t equal to 3 will be s is equal to ut plus half a t square. In which case, what is u? It's a freely falling body. Okay, so we can say that s here will be equal to half into, what is g? What is a? A is g because it is a freely falling body. So we have half into 10 into, what is t? T is 3. So it will become 3 square. So s at 3 will be equal to half 10 is 5 into 9, which is 45. So we can say that Sn is equal to 45 according to the question. Now, what is Sn? Sn is u plus a by 2 into 2n minus 1, which is equal to 45. Now, the time of travel is being asked, which means we've been asked to find out the value of n. U is 0, we know, a is 10. So we have 10 by 2 is equal to 2n minus 1. 10 by 2 into 2n minus 1 is equal to 45. Now, so 2n minus 1 would be equal to 2 into 45 is 90. We have 10 here. We'll cancel off. So we have 2n minus 1 is equal to 9. So we have 2n is equal to 9 plus 1, 10, which makes n is equal to 5. Therefore, the correct option becomes option C. A stone falls freely from rest from a height h and travels distance 9h by 25 in the last second. Okay, so u is given to be 0 and distance traveled in the last second, which means Sn is given us to as 9h by 25. Now, what is Sn? Sn is u plus g by 2 into 2n minus 1. So this is equal to 9h upon 25. Now, what is g? G is 10. So this is 10 by 2 times 2n minus 1 is equal to 9h by 25. So 2n minus 1 would be equal to 9 into 2 whole upon 25 into 10 into h. So this becomes 2n minus 1 is equal to 2 times 5 is 10. 9 by 125h. Now, for the complete motion, see, since the ball is dropped from a height h, what will be the final displacement? The final displacement would be h, in which case the final displacement s, equation s can be written as s is equal to ut plus half gt square. What is s here? S is h, so we have h is equal to u is 0, that means u is equal to half into 10 into t square. So h is basically 10 by 2 is 5t square. Now you may ask me, why did I come to this equation? Because this equation over here has two variables, one is n and the other is h. So now what we can do is we can replace h by t square, in which case let me just tell you, n is basically the second, so n is basically equal to t. Now if we correlate these two, what do we get? We get 2n minus 1 is equal to 9 by 125 into, what is h? H is given, h we just found it as 5t square. So now 5 times 25 is 125. So 25 will cross multiply. So 25 into 2 is 50n minus 25 is equal to 9t square is the equation. I always prefer solving the quadratic equation to 9t square minus 50n plus 25. So we have a is equal to 9, we have b is equal to minus 50, and we have c is equal to 25. In which case, what is x is, oh, no, not x, this equation is, what is t is equal to? T is equal to minus b plus or minus root of b square minus 4ac the whole upon 2a, which is equal to, what is minus b? Minus b is minus 50, so that becomes plus 50 plus or minus root of, what is b square? B square would be 2500 minus 4ac. What is 4ac? A is 25, 25 into 4 is 100, 109 is 900. So 25 into 4 into 9 whole upon 2 into a is 2 into 9, which is 18. So this is 50 plus or minus root of 2500 minus 25 into 4 is 100, 109 is 900, 900 the whole upon 18, which further gives us t is equal to 50 plus or minus root of 2500 minus 900 is 1600 whole upon 18. So t is 50 plus or minus 40 by 8. So t is either 50 plus 40 by 18 or t is 50 minus 40 by 18. So this is t is 50 plus 40 is 90, 90 by 8 is 5, 50 minus 40 is 10, 10 by 18 is 5 by 9. So t is either 5 by 9 seconds or 5 seconds. Now, what is the question? Are we asked to find out the value of t? No, we've been asked to find out the value of, what is the value of h is being asked to find out, right? So in order to find out the value of h, we need to come back to the equation. H is equal to, what did we find out? H is equal to 5 into t square, which means h is equal to 5 into, what is the value of t? T is either 5 or 5 by 9. So let us first find out for 5. So we have 5 into 5 square, which is 5 cube, which is 125 meters, which makes the correct option as option C. A stone falls freely from rest, and the total distance covered by it in the last second of its motion equals the distance covered by in the first 5 seconds. How many seconds? So again, a typical application of SN, but this time it's not to find out the height, it's to find out the time of motion. So we'll start writing by, we'll start solving the question by writing the formula. So what is given? Sn is equal to S at t is equal to 5 is been given. We can say that Sn is u by 2, sorry, Sn is u plus a by 2 into 2n minus 1, which is equal to ut plus half at square, and this would be at t is equal to 5. Since the ball is dropped from rest, u is equal to 0. So this becomes a by 2 is 10 by 2 into 2n minus 1 is equal to ut becomes 0, half into 10 into t is 5 square. Sorry, t is 5, so t square is 5 square. So 2 and 2 will get cancel off, 10 and 10 will cancel off. So what we have is 2n minus 1 is equal to 5 square, which is 25. So 2n is equal to 25 plus 1, which is 26. So n will be equal to 26 by 2, which is equal to 13, which makes the correct option as option C. A stone is dropped from the top of a tower and travels 24.5 meter in the last second. The height of the tower is. So Sn is given to be 24.5 meters. What is Sn? Sn is u plus a by 2 into 2n minus 1, which is given to be 24.5. Now, what is u? We know it's 0, a is 10, so we have 10 by 2 into 2n minus 1 is equal to 24.5. 10 by 2 is 5, so we have 2n minus 1 is equal to 24.5 by 24.5 by 5 is 5 4s are 20, 4.5, 4.9. So 2n is equal to 4.9 plus 1, which is 5.9. Therefore, n would be equal to 5.9 by 2, which is basically 2 point. 5.9 by 2 would be 19, 9 to 18, 10, 2.95. Now, the height of the tower would then be equal to, see, what is height of the tower? S is equal to half into gt square, which is 5 t square. N is t, so t is equal to n is equal to 2.95. So we have 2.95 the whole square. Now, I would say that being an MCQ question, the only point is to get the correct answer here. I will approximately take this value to be 3, in which case we have, oh, this is not half into 5, this is half into 10. So we have 5 into 3 square, which is 9, which makes the answer approximately as 45. The closest answer here is option A. A packet is dropped from a balloon which is going upwards with velocity 12 meter per second. The velocity of the packet after 2 seconds will be. See, so let us assume this to be the ground. The balloon is rising upwards and the speed is 12 meter per second. There is a packet inside this. See, at this height, at this velocity, we can say that the velocity of the packet is equal to the velocity of balloon. So when it is dropped, it will have the velocity of the balloon, which is 12 meter per second, acting in the upward direction. Now, acceleration due to gravity here is acting in the downward direction. So we'll take g to be negative g. And when we use the equation v is equal to u plus at, what we'll do is v is equal to, what is u is the initial velocity. Here is not, v of packet is not equal to 0 because it is going upwards with some velocity 12 meter per second. So that will be 12 meter per second plus, what will be the value of acceleration to gravity here? This we have to take it as minus 10 into time is 2 seconds. So that is into 2. So we get v is equal to 12 minus 20, which is minus 8 meter per second. Two balls are dropped to the ground from different heights. One ball is dropped 2 seconds after the other, but both strike the ground at the same time. If the first ball takes 5 seconds to reach the ground, then the difference in initial heights is. So let us just try to visualize the situation. So we have been given two balls. One is dropped like this, and the other is also dropped but it's dropped from different heights. Let us say this height. One ball is dropped 2 seconds after. So in both the cases, the initial velocity u is equal to 0. But if this is t1, then say if this is t2, we can say that t2 is basically t1 minus 2 seconds. Okay, so this is the given information. We need to find out um, the difference in the initial height. So this is the difference in the initial height. We also need to, okay, what else is given? Okay, if the first ball takes 5 seconds, so this complete travel takes 5 seconds for the first ball. These informations are given. So now let's try solving the question. So what can we say about, I'll take the first ball to be S1, displacement of the first ball to be S1, and that of second ball to be S2. So what can we say about S1? S1 is ut plus half gt square. Now what is the value of u? U is 0, so this is half g t square. I'll take g as 10, so 10 by 2 becomes 5, so this becomes t. T is t1 square, right? 5 t1 square. What is S2? S2 would be, okay, so if you have a doubt, how would I take half gt square? See, what is S? S is equal to ut plus half gt square. U is 0, so this becomes S is equal to half into gt square or 5t square. Instead of t, we have t1 because I have assumed s1 time in t1 and s1 displacement in time t1 and s2 displacement in time t2. So what is s2? S2 will be equal to half g t2 square, which is 5 t2 square. What is being asked to find out? The difference in initial heights. See, the difference in initial heights should be equal to the difference in displacement, because it is this distance which marks the only difference between these two bodies being dropped. So difference in initial heights is equal to S2 minus S1 or S1 minus S2. What is S1? S1 is 5 T1 square. What is S2? 5 into T2 square. Now, what is the relationship between T2 and T1? From here, we know that T2 is T1 minus 2. Now, what is T1? See, it is given in the question that the body took 5 seconds to come here, right? So, this is 5 into 2 square minus 5 into, oh, no, sorry, not 2 square. It should be, body took 5 seconds to come. So, the body took 5 seconds to come. So, it will be 5 into 5 square minus 5 into, the other body was released 2 seconds after. So, it should be 5 minus 2. So, 5 into 3 square, which basically gives us 5 into 5 square. I'll take 5 common. So, 5 into 5 square minus 3 square, which is 5 into 5 square is 25. 25 minus 9 is 5 into 16. So, 5 into 16 is 80. Therefore, the difference is 80 meter. Two balls are dropped from the same height at 1 second interval of time. The separation between the two balls after 3 seconds of the drop of the first ball is. This might sound a similar question, very similar to the last question what we did. The approach almost remains the same. Let us now try to get the analytical way out of it. So, two balls are drawn from the same height at 1 second interval of time. So here it goes like this. They are dropped from the same height, but this is dropped at t is equal to say t1, and this is dropped at t is equal to t2, which is t1 minus 1. Now, the separation between the balls. So again, what's been asked is displacement. So let us write the equation. So what would be S1? S1 would be 5 t1 square. What would be S2? I consider this as ball 1 and ball 2. So S2 would be 5 t2 square. Now, what is S1 minus S2? S1 minus S2 is 5 t1 square minus 5 t2 square. Now, let me just give you one more diagrammatic visualization of what's happens here. See, so at t is equal to 0, or say t1 is equal to 0, the object t2 has not yet started. At t1 being 1 second, t2 here would be equal to 0. At t1 being 2 seconds, t2 would be 1 second. At t1 being 3 seconds, t2 would be t2 would be equal to 2 seconds, and so on. So according to the question, we've been asked to find out after 3 seconds of the drop of the first ball. So after 3 seconds, which means at t1 equal to 3, t2 would be equal to 2. So this basically becomes 5 into, what is t1 square? 3 square, minus 5 into, what is t2 square? Is 2 square. t1 square, t2 square. So this becomes 5 into 9 minus 4, which is 5 into 5, and therefore the answer is 25 meter. So the correct option is option D, 25 meters. A ball is dropped from height h and another from 2h. The ratio of the time taken by the two balls to reach the ground is. So we know that the height h, say the displacement, s is equal to ut. Why should I write this again? It should be equal to, let's say, 5t square. Now, in this case, we have s1 is equal to 5t1 square, and second ball s2 is equal to 5t2 square. What is s1? Is the height from which the ball is dropped, right? So h is equal to 5t1 square, and s2 is 2h, given the question, equal to 5t2 square. Now, if you divide these two equations, what do you get? H by 2h is equal to 5t1 square by 5t2 square. So h by 2h, h and h by h is 1. So it is 1 by 2 is equal to t1 square by t2 square, which means if you take root on both sides, what do you get? 1 by root 2 is equal to t1 by t2. So the correct option is, well, this is not v2, it's root 2. So the correct option would be t1 is to t2 equals 1 is to root 2. So the correct option is option A.